Hello everybody. So today we will talk about longer derivative rules, rules to calculate derivatives. There are three rules like that. They are called product rule, quotient rule, and the third one is called the chain rule. So first product rule. So here is the rule. If a function k of x equals f of x times g of x, so that's why it's called product rule, then how to calculate the derivative? Well, first of all, we cannot say the derivative equals f derivative times g derivative. If it was plus or minus, then yes, it's correct. But if it is times, then the rule is more complicated. You cannot do derivative of f times derivative of g. Instead, you have to do derivative of f prime times g of x plus the other way around, f of x times g prime of x. And this rule is called the product rule. So it's a pretty long formula. And now I want to explain why this long formula takes place. Why is this correct? Well, like any rule, in order to explain why this formula is correct, we need to start with definition of the derivative as a limit. So here's the proof. Limit as x as h approaches 0 of k of x plus h minus k of x over h. So k of x is the same as f of x times g of x, and k of x plus h respectively is f of x plus h times g of x plus h. So the limit becomes f of x plus h multiplied gx plus h minus f of x multiplied times g of x over h. And now we want to do some algebraic manipulations to calculate something here to end up with this long formula. So how can we do that? So the idea is that we want to subtract and add the same thing in the numerator. And the thing that we subtract and add will be f of x plus h times g of x plus h minus, so what you want to subtract is f of x times g of x. F of x times g of x plus h. And then we add the same, f of x times g of x plus h. And then we subtract what we have in the original formula, f of x g of x. So we've got a pretty long formula. Now this long formula, once again, I have added and subtracted, first subtracted, then added the same thing inside the formula, so it doesn't change it. Now I will split the formula in two, and so the limit will split in two, so first limit of this part, and then limit of this part. Because it's a fraction, so each part will be divided by h. So it will end up like this. Limit as h approaches 0, f of x plus h times gx plus h minus f of x times gx plus h over h. And plus, and now I will express it as a separate limit. This minus this, so f of x times g of x plus h minus f of x times g of x over h. And now I will calculate each limit individually. Once again, we have two limits here. first limit we can factor out the common term, which is g of x plus h. So it becomes limit h approaches 0. We can factor out g of x plus h, and then we end up with f of x plus h minus f of x. All of that in parentheses, and factor out g of x plus h over h. And now h approaches 0. Now we can split it as product of two limits, like limit as h approaches 0 of this part, f x plus h minus f of x over h, times limit as h approaches 0, g of x plus h. Now the first limit is precisely the definition of the derivative f prime of x. And the second limit, when h approaches 0, x plus h becomes x plus 0, and so altogether it becomes g of x. So it will be f prime of x times g of x. That's how the first limit becomes f prime of x, or rather it equals f prime of x times g of x. Now the second limit is similar. Limit as h approaches 0, f of x times g of x plus h minus f of x times g of x. Divided by h equals, okay, so what we will do now, we will take out the f of x, which is the common term, and that becomes limit as h approaches 0. It's what I want to do. I want to do it right here. So I want to take g of f of x, take out. So it will be then g of x plus h minus g of x, and all of that multiplied times f of x. Now, like before, I want to split this limit into product of two limits of this times limit of this. But f of x is constant, so derivative of, a limit of f of x, because it's constant, is the same thing, so it will be f of x times, and then we have limit of this term, which is limit of h approaches 0, g of x plus h minus g of x over h, and again, by definition, it's nothing but g prime of x, the derivative, and altogether we get f of x times g prime of x. So combining this together becomes f plus f of x times g prime of x. That's the second limit. And these two limits together give exactly that long formula for the product rule. So once again, whenever there is a product and we need to do derivative, we need to do derivative of the first part times the second plus the first times derivative of the second. Once again, this is the product rule. Let's say that k of x equals x cubed times cosine x. And the question is to find the derivative. So to find the derivative, because there is a times here, so we have to apply this rule. And this rule is pretty straightforward. So we do the derivative of the first term. This is my f, and this is my g. So my f is x cubed, my g is cosine x. So simplify it a little bit by just multiplying minus times plus is minus, so it ends up 3x squared cosine x minus x cubed sine x. So this is how we apply the product rule. Now here's another example. Here's another example. Any example that states.
Блин, это надо запомнить.
Да, я вас понял. Или просто сделать как.
Смотри, скажи как, я тебе это сделаю.
Как? Here's another example. Product of two polynomials. K of x equals, say, 2x squared minus 5x plus 1 times x squared plus 2x at minus 3. Again, the question is to find the derivative. Now, in this problem, in fact, what we could do, we could just FOIL or multiply up these two polynomials. We could obtain one very long polynomial. It will start with 2x to the power 4, and it will be many terms. The last term will be plus 1 times negative 3, so the last term will be negative 3. And then we calculate this long polynomial, and then calculate the derivative using the power rule, and we will get the answer. However, this method is very long and not very efficient. The product rule actually gives much more efficient way to do it. So let's use the product rule. K prime of x equals, so in this case this is my f and this is my g. And to apply the product rule properly, here's what I want to do. I want to first put just parentheses and plus in the middle. So the first pair of parentheses will mean f prime, then g, then f, and then g prime in accordance to this rule. So since my f is 2x squared minus 5x plus 1, then my f prime will be 4x minus 5. My g is just this called x squared plus 2x minus 3. My f is the same as this one, 2x squared minus 5x plus 1. And finally, my g prime is the derivative of this, which is 2x plus 2. 2x plus 2. And that's it. So now we are not required, typically, we are not required to expand or anything, just stop like this, and this is the answer. So as you can see, the product rule gives a pretty fast way of calculating derivative of functions like this. So we apply this rule whenever there is a times. When there is quantity times another quantity, both quantities are functions of x, then we do apply the product rule, and this is how we calculate the derivative. Now the product rule is not necessary when we have a constant times a quantity. Then it will be the constant multiple rule. In fact, technically we could still apply that. So let's say f is a constant, but then derivative of the constant is 0. So it will be 0 times something will be 0, so this part will disappear, so it will be only this. And that's precisely what the constant multiple rule is. So it's the constant times the derivative of the function. So when you have a constant, so you don't need to apply this rule. Maybe I will do another small example with constant. Let's say k of x equals 5 times 2x squared minus 5x plus 1. So technically you could apply product rule here, but it will not be efficient. So let's try to do it like before. So derivative of 5 is 0 times 2x squared minus 5x plus 1, and then plus 5 times derivative of this, 4x minus 5. But 0 times anything is just 0, so this portion disappears, and we just have this, 5 times 4x minus 5. And now, if you look at the original function and look at the answer, So you see that this constant just becomes part of the answer. So that's precisely the constant multiple rule. So when you have constant times a quantity, then you better use constant multiple rule, just faster and gives you the same answer. But if you have function times another function, or quantity with x times another quantity with x, then you have to use